All right, what up, homeboys and homegirls? It's Coach Jakes back with another video to make your chemistry life a little bit easier. In this video, we're still focused on gas laws. We're going to talk about Avogadro's law, which examines the relationship between moles and volume. All right, basically, moles is independent. Volumes is going to be dependent on the number of, I said volumes. Volume is going to be dependent on the number of moles of gas you have. All right, so let's look at our example. Remember, this is going to be a before and after, an initial and the final, how it started and how it ended. So initially in this balloon, we have 1 mole of gas giving this balloon a volume of 22 liters. And so what we're saying is if we increase the moles to 2 moles of gas, then the volume will also increase. And notice that moles doubled, it went from 1 to 2. And so the volume is going to double, 22 to 44. And so because they both increased together, we say that it is directly, ooh, I left off that L, ooh, long day at school, directly proportional, all right, which means that they'll both increase or decrease together at the same ratio. So this was a multiple of 2, so that would be a multiple of 2. All right, now for our formula, we're looking at V1 over N1 equals V2 over N2. All right, so volume 1, our initial volume divided by our initial number of moles is going to be equal to our final volume over our final number of moles. All right. And so now let's go ahead and go to the problems, these 2 examples, and work them out and see what we get, right? So an underinflated tire has a volume of 6.1 liters. That's important because that's a volume. When filled with 1.7 moles, all right, that's good. We need that because that's going to be our N of air. If the number of moles is increased, all right, there goes our change. Increase means our change. So this means that this is how we started. Those are going to be our ones, initial. And the moles are increased to 5 moles. So now this is going to be our N2. What will be the new volume, or what will the volume increase to? So we're looking for V2. So we got V1, N1 equals V2, N2 equals. All right, let's go back and pull our numbers. We said V1 here is 6.1. N1 we said is 1.75 moles. V2 is going to be our X, and our N2 is going to be 5 moles, right? So now we're just going to use our formula again. V1 over N1 equals V2 over N2. And so what does that look like? And we plug our numbers in. For V1, we have 6.1 over N1, which is 1.75, is going to be equal to V2 is X over 5. Now, a lot of y'all, again, are going to probably feel like this step right here is not necessary. But I've seen so many of my kids mess up because they won't do this and then they switch the variables in the wrong spot, and then it's a done deal. So do this step and do that. Rewrite the formula and then plug in your numbers, okay? And so now if we cross multiply and divide, we'll get 6.1 times 5 for here. And then right there, you're going to get 1.75 times X. All right. And you should get that X is going to equal 17.7325 and some other numbers. All right. Keep it in mind, sig figs. We got 2 here, 3 there, 1 here, which means our answer can only have 1 sig fig, which means keep the greatest place value. All right, and the reason they can only have 1 sig fig is because everything's multiplying. So when you're multiplying, you just keep the fewest number of significant figures. All right, so we want to keep our tens place. Then we're going to look at the 1 to see if that stays the same if it rounds up. So the 1's place, which is a 7, is going to cause the 1 to round up to a 2. So you end up with 20, we found volume, 20 liters as your answer. All right, hope that makes sense. Now moving on to problem number 2. Party City has a flat balloon with a volume of 0.49 liters. So that's going to be a V. When fully inflated with 12 moles of air. So it says when fully inflated. So that means this sounds like it's a change. with 12 moles of air, so 12 moles would be our N2. The volume increases to this, so that's going to be our V2. So it makes this initial our V1. It says how many moles of air were present in the beginning. So if we're looking for moles of air in the beginning, all right, that means we're looking for N1. So set up again, we got V1 equals N1 equals V2 equals N2 equals. All right, plug it in. V1 is going to be 0.49 liters. N1 is actually our X now. V2, 7.28. And N2 is the 12 moles. All right, now using the same formula, so I can break it up. V1 over N1 equals V2 over N2. All right, we can plug in. For V1, we have 0.49. V1 right here, 0. Over N1. N1 is X equals V2 is 7.28 over 12. All right, because that's what our N2 is. Cross multiply and divide, so we end up with 0.49 times 12 equals 7.28 X. All right, and then when you multiply and divide, your X will equal 0.80769, and that is moles, right? But sig fig says this is 2, 2, 3. So it says we'll have 2 sig figs. We'll keep the largest place values. It means we'll keep the 8 and the 0. We're going to use the 7 to see if it rounds up. The 7 will round that 0 up to 1. So we end up with 0.81 moles of gas. All right, and that is Avogadro's law in a nutshell. All right, again, it's directly proportional because as the moles of gas increases, the volume will increase as well. And y'all know that because like when you blow up a balloon, the more air you put in there, that's the number of moles you're putting in that balloon. And so as a result, you will have more or a larger volume because you're putting more air in the balloon or the tire or when you're inflating a basketball or anything like that. So make sure you like this video, tag somebody that you need to tag it with, share it. I don't know, get people on board so they can come and get this chemistry goodness. All right, peace. Y'all have a good day.